Greetings from me to you wherever you're watching us from. You're welcome to mathematics class with Touchable Hygienus. I want us to look at this question. You see, we have root 2 minus 1 raised to power 10. You know, if this was power 2, we would simply split this into two brackets and probably multiply through, and then we simplify and get it. But this is power 10. How are we going to do that? This is power 10. Are we going to split into 10 brackets? No, it is going to be a waste of time and very difficult to obtain. So what we are going to do is, number one, we can decide to use binomial expansion. And what binomial expansion said is that if you have x minus y raised to the power of 10, it would be expanded as 10 combination 0 times the first term x raised to the power 10 and the second term y raised to the power 0. And then this 0 will be increasing from 0 till 10, while this 10 will be decreasing to 0. This 0 also will be increasing to 10 simultaneously. So we have minus, we have the next one will be 10 combination 1 times x. Instead of 10, it becomes 9. Instead of 0, this one increased to 1. Then plus 10 combination, this will increase to 2 times x, this will reduce to 8, and then y will increase to 2. Then minus 10, this will increase to 3 from 2 times x, this will reduce to 7 times y will increase to 3. Plus 10 combination, this will increase to 4 times x raised to power, this will reduce to 6, and y will increase to 4. Minus 10 combination, this will increase to 5, x will reduce to 5 from 6, and y will increase to 5. Plus 10 combination, this will increase to 6, x will reduce to 4, and y will increase to 6. Minus 10 combination will increase to 7 from 6, times x raised to power will reduce to 3, and then y will increase to 7. Plus 10 combinations 8 from 7 times x raised to power 2, and then y raised to power 8. Minus 10 combination 9, x will reduce to 1, and y will increase to 9. Plus 10 combination 10 from 9 times x will reduce to 0 from 1, and then y will increase from 9 to 10. That is how it is being expanded. You see, this is increasing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one is decreasing. This one also increases simultaneously with this. Why this is decreasing? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. You will now also notice that the sign is alternating. This is positive, this is negative, this is positive, this is negative, this is positive, negative, positive, negative, positive, negative, positive. The sign alternates because the sign between the two items is negative. If this is plus, it will be plus all through. But since this is negative, you alternate the sign plus, minus. Okay. So if we apply what we have here to our question, it is right for us to say that root 2 minus 1 raised to the power 10 by binomial expansion is going to be 10 combination 0 times root 2 raised to the power 10 times 1 raised to the power 0 minus 10 combination 1 root 2 times root 2 raised to the power from 10 to 9 times 1 raised to the power 1 plus 10 combination 2 times root 2 raised to the power 8 times 1 raised to the power 2 minus 10 combination 3 times root 2 raised to the power 7 times 1 raised to the power 3 plus 10 combination 4 times root 2 raised to the power 6 times 1 raised to the power 4 minus 10 combination 5 times root 2 raised to the power 5 times 1 raised to the power 5 plus 10 combination 6 times root 2 raised to the power 4 times 1 raised to the power 6 minus 10 combination 7 times root 2 raised to the power 3 times 1 raised to the power 7 plus 10 combination 8 times root 2 raised to the power 2 times 1 raised to the power 8 minus 10 combination 9 times root 2 raised to the power 1 times 1 raised to the power 9. Then finally plus 10 combination 10 times root 2 raised to the power 0 times 1 raised to the power 10. And we have expanded that. Then we begin to simplify. I wouldn't want us to simplify all together. I want us to take it gradually. Let us take the combination first. 10 combination 0, if you punch in your calculator, you will have 1 times 2 raised to the power 10. Let's leave it like this for now. Then 1 raised to the power 0 is still 1. Then minus, because any number raised to the power 0 is 1. 10 combination 1 is 10 if you punch in your calculator, times root 2 raised to the power 9 times 1 raised to the power 1 is still 1. Plus 10 combination 2 will give you 45 if you check in your calculator, times root 2 raised to the power 8 times 1 raised to the power 2 is still 1. Then minus 10 combination 3 will give you 120 times root 2 raised to the power 7, 1 raised to the power 3 is still 1. Plus 10 combination 4, it's going to give us 210 times root 2 raised to the power 6 times 1 raised to the power anything is still 1. And then minus 10 combination 5 is going to give us 252 times root 2 raised to the power 5 times 1 raised to the power 5 is still 1. Plus 10 combination 6 is going to give us 210 times root 2 raised to the power 4, 1 raised to the power 6 is still 1. Minus 10 combination 7 is going to give us 120 times root 2 raised to the power 3 times 1 raised to the power 7 is still 1. Plus 10 combination 8 will give us 45 times 10 raised to root 2 raised to the power 2 times 1 raised to the power 8 is still 1. Then minus again, 10 combination 9 will give you 10 times root 2 raised to the power 1, which is root 2, times 1 raised to the power 9 is still 1. Then plus 10 combination 10 is 1 times root 2 raised to the power 0. Any number raised to the power 0 is still 1. And 1 raised to the power 10 is still 1. Okay? We've been able to simplify this. Let us also now simplify the root. Root 2 raised to the power 10 is going to give us 32. So we have 1 times 32 times 1 is still 32. Minus 10 times root 2 raised to the power 9 is going to give us 16 root 2. Okay? Times 1. Plus 45 times root 2 raised to the power 8 is going to give us 16 times 1. Minus 120 into root 2 raised to the power 7 is 8 root 2 times 1. Plus 210 root 2 raised to the power 6 is going to give us 8 times 1 is still 8. If we simplify further, this is equal to 32 minus 10 times 16 is 160, then root 2. 45 times 16 is 720 minus 120 times 8 is 960, then root 2, plus 210 times 8, we have 1680. These ones that are not carrying root 2. 32 plus 720 plus 1680 plus 840 plus 90 plus 1 is going to give us 3363 minus these ones that are carrying root 2 minus 160 minus 960 will give us 2378 root 2, and that is the answer. But this is binomial expansion. Is there any other way we can solve this question? Let us look at this method. One can decide to say, okay, root 2 minus 1 raised to the power 10. What if I say let x be equal to root 2 minus 1? Take note of this. That means that this is going to be x raised to the power 10. And if this is x raised to the power 10, noting that x is this, I would say that x raised to the power 2, let me take it gradually, is going to be root 2 minus 1 raised to the power 2. And if I expand this, x squared will be root 2 times root 2. You know how we expand into two brackets and multiply out? We are going to have 2 minus 2 root 2 plus 1. And that is going to give us 3 minus 2 root 2. So x squared is 3 minus 2 root 2. We've gotten 12 in now. We are looking for power 10. If we square this x squared to have x raised to the power 4, this is going to give us 3 minus 2 root 2 squared, because this is x squared. So if you square x squared, it means squaring this. And if we expand x raised to the power 4 is going to be, we also split this into two brackets and multiply out. We are going to have 3 minus 2 root 2 into another 3 minus 2 root 2. And that will give us 3 times 3 is 9. 3 times minus 2 is minus 6 root 2. Minus 2 times 3 is minus 6 root 2. And then 2 times minus 2 times 2 here is 4. And then 2 times root 2 is 2. 4 times 2 you have 8 here. And this is going to give us 8 plus 9 is 17 minus 12 root 2. That is for x raised to the power 4. Okay? If we square it again, it's going to be x raised to the power 4 squared, which is x raised to the power 8. And that is squaring this because this is x raised to the power 4. So we have 17 minus 12, root 2 raised to the power 2. If we, you see, we're coming close to 10. If we expand this again into two brackets, we are going to have that x raised to the power 8 is equal to 17 minus 12 root 2 into another 17 minus 12 root 2. And that will give us 17 times 17, 289. 17 times 12 and 12 times 17 added together will give us minus 408 root 2. And then minus 12 times minus 12 will give us 144. And then times 2, we have plus 288. When we add this and this, we have 577 minus 408 root 2. That is for x raised to the power 8. If we square this again, x raised to the power 8 raised to the power 2 will give us x raised to the power 16, which is more than what we are looking for, x raised to the power 10. So it is going to be wrong for us to square again. So what then are we going to do? We know that x raised to the power 8 times x raised to the power 2 by the law of indices is x raised to the power 8 plus 2, which is x raised to the power 10. So if we've gotten x raised to the power 8, and we know x raised to the power 2 from onset as this is x raised to the power 2, and this is x raised to the power 8. So x raised to the power 8 times x raised to the power 2 will be equal to this times this. So we bring the two brackets, 577 minus 408 root 2 times 3 minus 2 root 2. So this is x raised to the power 8 and this is x raised to the power 2. So we expand this 2. We multiply out. 577 times 3 will give us 1731. 577 also times minus 2 root 2 will give us minus 1154 root 2 minus 408 root 2 times 3 will give us minus 1224 root 2. Then minus 408 root 2 times minus 2 root 2 will give us plus 1632. And finally we collect like terms. This and this are like terms, so we sum them to have 3363. This and this are also like terms. We sum to have minus 2378 root 2. And that is our answer, the same as the first one, but we didn't use binomial expansion here. So the one you prefer. Let us look at one more method. The question is root 2 minus 1, remember, raised to the power 10. I will say let x equals root 2 minus 1. If I make root 2 subject of the formula here, I will have root 2 equals x plus 1. And then you square both sides so that you have root 2 raised to the power 2 equals x plus 1 raised to the power 2. So this root we cancel the square so that 2 equals x plus 1 raised to the power 2. And 2 equals, when we expand this, we have x squared plus 2x plus 1. We'll make x squared the subject of the formula because x is already this. I want to find x squared. If you make x squared the subject of the formula here, I'll have x squared equals 2 minus 1 minus 2x. So x squared will be equal to 2 minus 1 is 1 minus 2x. So this is x squared and this is x. If I square this, I will have x squared squared is going to give me the square of this, that is 1 minus 2x squared. X raised to the power 4 will be equal to, if I expand this, I will have 1 minus 4x plus 4x squared. But this is becoming complicated. I don't want this squared. So I'll have x raised to the power 4 equals 1 minus 4x plus 4. Instead of x squared, I will replace that x squared with 1 minus 2x. So this is 1 minus 2x. So if I simplify further, x raised to the power 4 is going to be equal to 1 minus 4x. 4 times 1 will give us 4. 4 times minus 2x will give us minus 8x. Then x raised to the power 4 will be equal to 1 plus 4 will have 5, minus 4 minus 8 will have minus 12x. This is raised to the power 4. If I square again, I have x raised to the power 4 squared is equal to 5 minus 12x squared. And this is x raised to the power 8 equals, if you square this, you know you split into two brackets and expand. So I have 5 times 5, you have 25. 5 times 12, you have minus 60x, minus another 60x, then plus 144x squared. And then x raised to the power 8 equals 25 minus 120x plus 144x squared. But I don't want to see this x squared, so I will replace it with 1 minus 2x. So x raised to the power 8 equals 25 minus 120x plus 144 into 1 minus 2x. And x raised to the power 8 will give me 25 minus 120x plus 144 times 1 is 144. 144 times minus 2 is minus 288x. So x raised to the power 8 equals to collect like terms. 25 plus 144 will give us 169. Minus 120 minus 288 will give us minus 408x. This is x raised to the power 8. If we square again, it will be x raised to the power 16. So we are not going to square again. So what have we gotten? We've gotten so many things. We have x squared. So let's bring them out. We say that x equals to root 2 minus 1. X squared, we got it as 1 minus 2x. X raised to the power 4, we got it as 5 minus 12x. And x raised to the power 8, we got it as 169 minus 408x. Now we are looking for x raised to the power 10. So if we see this, x raised to the power 10 is going to be equal to x raised to the power 8 times x raised to the power 2 from our law of indices. So x raised to the power 10 is equal to x raised to the power 8 has already been gotten as 169 minus 408x times x raised to the power 2, we got it as 1 minus 2x, and we expand again. This is equal to 169 times 1 is 169. 169 times minus 2x will give us minus 338x. Minus 408 times 1, we have minus 408x also. Minus 408x times minus 2x will give us plus 816x squared. Then this will give us 169 minus 338 minus 408 will give us minus 8 plus 8 is 16, 6 carry 1, 4, 7x. Then plus 816x squared. I don't want to see x squared, so I'll replace it with this. This is x squared, 1 minus 2x. So this will give me 169 minus 746x plus 816 times 1 is 816. 816 times minus 2x, we have minus 231632x. When we collect like terms, 169 plus 816 will give us 985. Minus 746x minus 1632x will give us minus 2378x. So this is x raised to the power 10. But remember, it is not x that it was originally. It was originally root 2 minus 1. So what we are looking for is root 2 minus 1 raised to the power 10. And it is going to be equal to 985 minus 2378 into root 2 minus 1. So that is going to give us 985 minus 2378 root 2 will give us 2378 root 2. Minus 2378 times minus 1 will give us plus 2378. And that is 985 plus 2378 will give us 3363, then minus 2378 root 2. And that is our answer as we got before. you can look at it very well and choose the method that is easier and more convenient.